Oh, sorry. It's 4:12 in the morning. I've already taken a shower, gotten dressed. I'd like to thank my dog. You ever think about getting a dog? Remember, sometimes they wake you up really early, like 3:30. Well, maybe 2, then 2:30, then 3:30, and that was it. I was done. Over, out. Glasses look dirty. Woo wee. Let me take this opportunity to welcome you to my first review session for that New York State Regents exam. Today we're going to be discussing two things. We're going to be discussing linear or inequalities and graphing them, as well as, here we go again, pink, pink, as well as some complex fraction work. All right, so I'm going to get through, I don't know how many problems, probably 20 problems maybe. I don't know, but it didn't come out very well. Huh. Oh yeah, it did. It's fun. All right, so let's get going. I say we got three kinds. Not sure why I say three kinds. I think we'll get there when I get there. So thanks for joining me. So the first thing I want you to understand is when you're doing these. Oh, I got it. You got the. All right. First thing I do is get the weird thing alone. All right, and just like normal solving equation, you want to get the weird thing alone. Oh, there it is. So the weird thing is this absolute value here. It's the same thing when you're doing radicals or whatever. You got to get that weird thing alone. So what we're going to do is we're going to add 2, bring it over. And so we end up with 3 absolute value 2x. I don't know why I didn't put it over here. That would have made more sense. Over 3 is less than or equal to 10. All right, or 12. Told you. I need me some more Brugger's toffee because clearly my brain's not functioning yet. We don't have the weird thing still alone. We still have this 3 we got to get rid of. So what we're going to do is divide by 3. Divide by 3. So now I have absolute value of 2x plus 6 over 3 is less than or equal to 4. Got that right? Once you've done that, then what we're going to do is we're going to break it up into 2 problems. The original and the modified version. So the original would be 2x plus 6 over 3 less than or equal to 4. And then you don't change the left side at all. You don't mess with it. 2x plus 6 over 3. Leave the left sign alone. Everything else changes. And that's going to be true for all absolute values. So this will be greater than or equal to negative 4. All right. So the easiest way, I didn't give myself enough room for this. The easiest way to handle this, don't cross multiply. Don't do that crazy stuff on, especially on inequalities. We're going to just multiply this side by 3, and we're going to multiply this side by 3 in order to get rid of this 3. And as long as you multiply by the same thing, it's okay. If that was a negative 3, then you'd have to flip the sign, but we don't have to do that. So we get 2x plus 6 is less than or equal to 12. Subtract 6, and I get 2x is less than or equal to 6, or x is less than or equal to 3. I'm gonna stop showing those in between steps because I'm running out of room. So I gotta find all right, we're gonna somehow I'm having a problem tracking 3. We're gonna multiply by 3, and we're gonna multiply by 3. Bing, bing, and I get 2x plus 6 greater than or equal to negative 12. Subtract 6, I get 2x is greater than or equal to, remember we're subtracting 6, negative 18. And divide by 2, and I get x is greater than or equal to negative 9. Now you are not really able to tell whether or not this is going to be an and or an or, a conjunction or a disjunction. We got to decide. So the easiest way to do that is give me a quick sketch of the answer. Just do it right here. Here's negative 9. And we said greater than or equal to that. So that would be going off in this direction. And here is 3. And we said less than or equal to that. close circle. And since we're combining in between these two, that we need an and form. So, simplest way to write it is -9 here, 3 here. Because it's in the middle, x goes in the middle. And the signs are whatever these signs are, less than or equal to. Both of them have to be, it's always less than. As long as the small number's on the left, it's always less than. You just got to decide if you're going to need the equal to. I'll try to be neater on the next one. That was kind of sloppy. There it is. All right, so that's one type. That's a linear type. All you do is move things over and solve two different equations. Now, when you're dealing with quadratic, all right, what we're looking for here is less than 0. All right, and so what I want to do with this is I want to decide when it is negative. That's what less than 0 means. I think they're both less than 0. Okay, if it was greater than 0, I would be looking for when it is positive. But now I want to look for when it's negative. So what I do, the first thing I'm going to do is factor this. X, this is -6 and -2. They multiply to +12 and add up to -8. So my two critical numbers are x equals 2 and x equals 6. These are my two critical numbers. They're going to tell me where to start looking on my number line. So 2 and 6. They, in effect, break this number line up into 3 segments. 1, 2, and 3. 3 areas you need to test. You need to test a number down in this area, like x equals 0. You need to test a number in the middle, like x equals 4. And you need to test a number like up here, x equals 10. Just a number in each area to see if it works, to see if it turns out to be negative. So I'll do that using, I wish I had a better color. Oh, I can pick purple. I'm going to pick purple. Ooh, look, they added purple. All right, so we're going to use purple. So I'm going to try 0. 0 minus 2 is -2. And 0 minus 6 is -6. So when I multiply them, because remember we're multiplying right here, we're multiplying, -2 times -6, all of this area will be positive. All right, so let me erase that. Now I want to test 4. 4 minus 2 is 2. 4 minus 6 is -2. +2 times -2 in this whole area, any number I test, doesn't matter what number it is, it will be negative. And now I'm going to try 10. I think you know what's coming. 10 minus 2 is 8. That's positive. 10 minus 6 is +4. And 4 times 8 is 32. But more importantly, it's positive. And then I decide, okay, where do I want to look? I want only the stuff that's negative. So I need only the stuff that's negative. Well, only the stuff that's negative is between 2 and 6. So all of this. So my answer then is +2 less than x less than 6. Not equal to, because we didn't have equal to 0. Done. Rational. We're going to do these basically the same way, but in this case, the denominator gives us a number. It gives us the critical number of x equals 1. This is also a restriction in the domain. So x can never equal 1. As a matter of fact, I'm going to change this to less than or equal to, just to show you something. All right, the numerator I'm going to factor to x minus 4, x plus 2. So my two critical numbers from the numerator are going to be x equals 4 and x equals -2. So now I have three critical numbers, -2, +4, and 1. So I've got more areas to test. I now have 4 areas to test. -2. We'll put 4 up here. And 1. 1 is actually kind of like right in the middle. Actually, I don't like the way I did that, so let me erase that. Put 4 here. Put 1 here. Put -2 here. And I got a number line. So now I've got 4 areas to check. I got to the left, in between these two, in between these two, and to the right. So let me grab my red pen. Over here, I'm going to check the number. I'm just going to test the number x equals -10. Here, I'm going to test, because I can, x equals 0, x equals 3, and x equals +10, just to see what happens. All right, so let me put this over here. So if I plug -10 in, if I plug -10 into that, -10 minus 4, negative. If I plug -10 into that, -10 plus 2, negative. If I plug -10 into that, -10 minus 1, negative. 3 negatives make a, you guessed it, negative, negative, negative. All right, let's check the next number. So now we're going to try 0. If I plug 0 in for that, negative. If I plug 0 in for that, positive. And if I check 0 in for that, negative. 2 negatives make a positive. Now we're going to test 3. If I plug 3 in here, positive. If I plug 3 in here, positive. If I plug 3 in here, negative. 1 negative, an odd number of negatives makes a negative. I know I haven't looked up in a while. An odd number of negatives, that's what we're really looking for. 3 negatives, any 2 negatives make a positive, so 3 negatives make a negative. Any even number of negatives makes a positive, and then when you have only 1 negative, that's negative. And then you guessed it, the last step would be positive. So I want the area where it's less than or equal to 0. That's negative. So I want this area, and I want this area. So let's figure out how we're going to write that. This case, it's going to be x is less than -2 or equal to. This one's going to be a little tricky because remember, 1 is not in the domain. It cannot be 1. So it's really an open circle here and a closed circle here and everything in between. So in this case, x goes in the middle, less than or equal to 4. But because we can't equal 1 because it's not in the domain, it's got to be just strictly less than 1 or greater than 1. All right, and since it can be this or this, I have to also write the word or. Kind of tough. All right, let's go through some practice problems. Weird things alone. Since the weird things alone, we'll break it up into 2 separate problems. Absolute value of -4x. Get rid of the absolute value. We're breaking it up into 2 problems. -4x plus 5 is less than 13. -4x plus 5 greater than -13. All right, now we just got to solve these. Now, your radar and alert beeper should be going off because of this negative here. What do you have to remember to do when we eventually divide by that -4? Do you remember? Well, let's see what we remember if you get to it. I'm going to subtract the 5 and bring it over, so I get -4x is less than 8. Divide by -4. Divide by -4, and you guessed it, x is greater than -2. You must remember to flip the sign. We don't know if it's an or an and yet until we're done. Subtract the 5, I get -4x greater than negative 18. Divide by negative 4. Divide by negative 4. And this is when the child comes out. This is gross. We flip the sign. Two negatives make a positive, and this is 9/2. I must have done something wrong. I didn't come up with a nice number. Whatever. All right, kids. We have to decide if we're going to put an or an and in between these two. Here's negative 2. We're going to go not equal to and greater than. Or we can just go fill a line this way if you want. 9/2 is like 4.5, so we'll put 9/2 up here. And open circle going this way. So this is clearly an and. We put the x in the middle, both less thans, not adding equal tos, -2 and 9/2. By the way, if you're asked to do this in interval notation with the parentheses and brackets, in this case, since they're both less than, not equal to, we're going to use parentheses for both of them. And we'll just do parentheses, -2, 9/2. This would be interval notation. All right, there's my answer, or this one. All right. So in order to do these, we first have to set this equal to 0. So we're going to bring the 10 over. I think I'm going to be drinking coffee all day today. -10 greater than 0. Then I got to go to an awards ceremony tonight. Yay! All right, let's factor. Factoring's sort of simple. X minus 5. X plus 2 greater than 0. This is going to give us our two critical numbers, and that gives us 3 areas to test. Remember, this is a quadratic one. So this is x equals 5 and x equals -2. So we got to test our areas. -2 and +5. So we're going to test, I'm going to test the numbers x equals -10. I'm going to test the number x equals 0. And I'm going to test the number x equals +10. Now, I am looking for, what am I looking for? I'm looking for when it is greater than 0. Greater than 0 means positive. Greater than 0 means positive. I'm looking for positive. So if I put a -10 in, that makes that negative, that makes that negative. So this area is negative. If I put a 0 in, negative, oh wait, a negative times a negative is positive. Ooh, man, almost made a dumb mistake. Because I'm going to put it in here, it makes it negative. I put it in this one, it makes it negative. That makes it -15 and -8. Clearly negative. Now I'm going to plug in 0. Negative. And 0 plus 2 is positive. So in this area, it's negative. And if I put in 10, 10 minus 5 is 5. That's positive. 10 plus 2 is 12. That's also positive. Positive times positive is positive. And I'm looking for it to be positive. So I'm looking for open circle going this way. And I'm looking for open circle going that way. So my answer is, and I'll do this in interval notation and I'll do it in standard notation. X is less than -2 or X is greater than 5. And then if I did it in interval notation, that would be -infinity to -2 union 5, +infinity. All right, we're moving. All right, so this is rational. So I'm just going to get my two critical numbers. Well, in this particular case, I think what I would do on this particular case is just get my critical numbers and test my intervals. So probably should have worked this one out ahead of time. I hate problems like this. Oh, this was a multiple I think this was a multiple choice question. I turned into a regular one because if it's a multiple choice question, you can just test certain areas. So happened? Where'd it go? Oh, here we go again. Lost it again. Still there? I lost my whole mouse pointer. I think I got it back. All right, here we go. All right, so in order to add these, you have to have a common denominator. So we're going to multiply both numerator and denominator times x minus 2. Multiply the denominator by x minus 2. Multiply the numerator by x minus 2. So I've got, in the denominator, I have x minus 2. In the numerator, I have x plus 16. Now, what I'm going to do here is distribute this negative 7 into both these. So that's minus 7x plus 14, less than or equal to 0. So this gives me negative 6. In the numerator, I'm going to have negative 6x plus 30. So now I'm going to get my two critical numbers. My two critical numbers are what makes this undefined, x equals 2, and what makes the numerator equal to 0, x equals 5. So those are my three critical numbers, my two critical numbers. Man, losing my mind today. So my two critical numbers are x equals 2 and 5. So I'm going to check those. Let me put this back up in parentheses. So negative 6x plus 30 over x minus 2, and I'm looking for less than or equal to 0. So I'm going to plug in 0. X equals 0. That would make this negative. That would make this positive. Negative over positive is, in fact, negative. Now I'm going to try x equals 3. Or, excuse me, yeah, x equals 3. That would make this positive. Negative 6 times 3 is negative 18 plus 30. That would make this positive. So positive, positive, positive. And then I'm going to plug in like 10. That would make this positive. But negative 6 times 10 is negative 60 plus 30. That would make this negative. All right, so running out of room because I wrote too big. Writing my answer then. My answer is simply x is less than, because I'm looking for less than or equal to 0, less than or equal to, wait a second, can we equal to? Are we able to equal to? We're not able to equal to, so I got to get rid of that equal to. So less than 2, or x is greater than or equal to 5. All right. The heights h of, if you got this, go on. If not, you will keep going here. So the heights h of students, blah blah blah, determine the interval in which these heights lie and express your interest. So we're going to split this. It's already got the weird thing alone, so we're going to split the weird thing up into two equations. H minus 57.5 over 2 less than or equal to 3.23, and h minus 57.5. No, notice no change on the left, but the right side changes. Greater than or equal to 3.23. Negative 3.23. All right, to get rid of that 2, we're just going to multiply both sides by 2. I don't know what I'm doing. All right, so I get h minus 57.5 is less than or equal to 6.46, or h minus 57.5 is greater than or equal to negative 6.46. We're going to add 57.5, so 6.46 plus 57.5. 63.96. H is less than or equal to 63.96. Here we're going to take negative 6.46. And we're going to add again 57.5, and this one gives me 5104. So h is greater than or equal to 51.04. Round to the nearest tenth of a foot. me go back, make sure I got this. 63.96. So, round to the nearest tenth of a foot, they're going to be between 51.0. Make sure I rounded this one right. Oh, it's 51.04. Good thing I looked. See, I made that mistake. 51.04. So 51.0 less than or equal to h less than or equal to, and I'm going to round this one to 64.0. So there's my answers. Moving on, kind of crazy. Another quadratic. So we're going to get x squared minus 4x minus 5 greater than 0. Factoring is not too difficult here again. X minus 5, x plus 1. That gives us our two critical numbers of x equals 5 and x equals negative 1. Check the number line. Negative 2. Why did I write negative 2? Negative 1 and 5. So I'm going to test the number down here, which is like 0. X equals negative 10. That would be negative and negative. If I put it in this one, it's going to be, if I put it in this one, it'll be negative. If I put it in this one, it'll be negative. So negative times negative is positive. If I put in 0, this one would be negative, but 0 plus 1 is positive. Negative times positive is negative. And if I put a big number in like 10, this would be positive, this would be positive, so this whole area would be positive. I'm looking for greater than 0, that's positive. Hold on, I gotta get my dog. Alright, hope he doesn't make too much noise. Alright, here we go. Okay, so this is a slightly different problem. We've got the absolute value, which is already isolated by itself, is greater than this. So we can split it up. Don't change the left side. Absolute value greater than 2a minus 3. Then we switch everything else. A less than the negation of the entire left side. Pen's dying already. I wonder why. So, solve this. Subtract 2a. Subtract 2a. And I get negative a is greater than negative 3. Divide by negative 3. Divide by negative 1. Divide by negative 1. God, I think I need more coffee. So, a is less than positive 3. Notice I switched the sign. My pen is just acting up. I don't know what's going on. Is this thing done here? That's all done. That's done. Alright. This one is gives me a is less than negative 2a plus 3, because distributing the negative. And this gives me 3a is less than 3 or a is less than 1. Again, I don't know if... Interesting. Interesting problem. Because this is going to give me something that I don't normally look at. 1 and 3 less than 1 and less than 3. I'm going to test something. Let's try 2. If I plug a 2 in here, is 2 greater than 4 minus 1? Yeah. What if I type in 3? 3 is not. How about 0? 0 greater than 2, 0. So I guess the answer is, strange answer. X is less than 3. If I plugged in a 2, that's a weird problem. I don't like that problem. I don't know why I put it on there. Modeled by this equation. The store's profit for these sales is modeled by this. P equals this. Profit minus cost. What is the minimum of our calculations to be sold for the profit to be greater than the cost? All right, so this is just kind of one of those thinking person questions. Of course, I don't know where my pen is. In order for the profits to be greater than the cost, we'll do profits minus cost has to be, if the profits are greater, then this is going to be greater than 0. So 500x minus my salary, here's my salary, 3.2 million. Yeah. Plus 60,000 has to be greater than 0. I wonder why I gave like no room to do this problem. Alright, so the order to do this problem, what we're going to do is, what are we going to do? We're going to find a common denominator. Our common denominator is going to be x, so we're going to put this over x, make this 500x squared, put this over x, that's fine. And we're going to put this over x and make this 60,000. I think I added too many zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4. I got too many zeros. 60,000x. Alright, so this gives me 500x squared plus 60,000x minus 3.2 million greater than or 0. All over x. All over x. Well, now I'm going to factor the numerator. This is why I can't believe I didn't give it enough room here. This is kind of crazy. I'm going to take out a 500. So let's do that math. 60,000. So you guys see where I came with the numbers. Divided by 500. You get 1,200 because 6 times 5 is 120. And then I do 3.2 million. This is very familiar to me. Divide that by 500. And I get 6,400. So I'm taking out the GCF of 500. So the factoring is easier, and I end up with x squared plus 120x minus 6,400. 6,400 all over x is greater than or equal to 0. So now what I want to do is just factor this thing, and the factoring here is a little bit tricky, but not too difficult. The answer is x minus plus 160 and x minus 40. Let's just check. 160 times 40. 6,400. Now, for those of us that have this calculator, you could have immediately just done this. Menu 3, 3, 1. It's a second degree polynomial. You didn't even have to take out the GCF. You just could have put 500. Then you could have put in 60,000. I hope that's 60,000. 3, 4, 6. Okay. And then this one's going to be kind of tricky. So 3, 2, 0, 0, 0, 0, 0. Hit enter. Make sure I got it right. 500x squared, 68,000x minus 3.2 million. Hit enter. Oh, I didn't put minus. Damn it. Doggone it. Shooty. Toots. Sorry. Clearly that's not going to work if that's a plus. Hit enter. So there's my two answers. Negative 160 and 40. So that's what I get here. Negative 160 and 40. So what is the minimum number of calculators that need to be sold? The answer is going to be x equals 40. All right, let's get off that problem. It's a pain in the neck. Might get rid of that one. All right, so here it looks like, and then I go to the easy problem. Just take out a GCF, x times x minus 3 less than 0. Again, we're looking for negative. So we've got our two critical numbers of 0 and 3. 3 from here. And then we test three areas. Let's try negative 10. That would be negative. That would be negative. So that's positive. Try 1. Positive, negative, negative. Try 10. Positive, positive, positive. I want negative. So 0 less than x less than 3. get the weird thing alone. So you're going to divide by -3. Divide by -3. And I get 6 minus x, absolute value, is greater than 5. Greater than 5. Then we're going to split it up. I'm actually going to switch this problem before I do it in class. And I get 6 minus x greater than 5, the original problem, and now the modification of the problem. 6 minus x less than -5. All right. And this shouldn't be 6x. So I get negative x is greater than -1. Divide by -1, I get x is less than 1. Over here, I'm going to move the 6x over. I get negative x is less than -11. Divide by -1, I get x is greater than 11. And this is 11 going this way. This is 1 going this way. So this is clearly an OR case. So there's your answer. Sometimes you get some multiple choices where you're just going to test numbers. Oh, yeah, do you remember that problem I was telling you about earlier? Up here, x plus 16, x minus 2. Isn't it this one? I don't remember what we came up with. What we came up with is an answer up here. Hopefully, we're going to less than 2 or greater than or equal to 5. So I'm going to guess it's probably this one right here. But what you could do is just test numbers. Like if I test 0, 0 plus 16, and 0 minus, so that'd be 16 over -2. That's negative. 16 over -2 is negative, so negative is less than 7. Anything negative is going to be less than 7. So 0 works. So 0 has to be in the answer. That means this can't be the problem answer, and that means this one can't be the answer. So now I want to test a number that this one doesn't have, like 10. 10 plus 26. Well, I'll test 5. I don't know. Let's just see if 5 should work. 5 plus 16 is 21 over 3. That's 7. Now let's test, it doesn't matter, 10. 26 over 8. 26 over 8. Isn't that a little over 3? Which is less than 7. And that works. And there's where that's the right answer. So I told you that was going to be, that should have been a multiple choice question, because that was a really difficult question to do that wasn't, if it's not multiple choice. If it's multiple choice, you just got to check answers. That's all you got to do. Over here, we got another multiple choice question. Let's try this one. We're just going to test numbers. First number I'm going to test is 0, because if 0 works, then it's one of these two. If 0 doesn't work, it's one of these two, and 0 is just a really easy number to test. So if I plug in 0, the numerator becomes -5 over 3, which is really positive 5/3. And since the numerator is bigger than the denominator, that's larger than 1. So 0 works. So these answers are out. So now I'm just going to figure out what the difference between these two is. Oh, anything on the outside. So let me try 10, because 10 is going to be over here. So, get my eraser. So if I try 10, this gives me 40 minus 5, which is 35 over 3, which is like over 10, right? And 10 is over 1, so there she goes. That's our answer. And that's all she wrote. All right, we're done with inequalities. We're going to start complex fraction now. We're going to do those for a little while. So when I do complex fractions, what I like to do first is to make everything into a fraction, just to kind of get a look at it like that. Over 1, put this over 1. And then I look at all the denominators. I'm going to highlight them for you. X squared, x, 1, 1, and x. The lowest common denominator, not the lowest denominator, but the lowest common denominator in this case is x squared. So I'm going to put an x squared next to every fraction. If your teacher doesn't do it this way, it really makes life easier. X squared. You'll see why in a second. So nothing cancels here. I'm left with x squared. Over here, one of these x's cancels with one of these x's, and it leaves me minus 4x. all over. Over here, nothing cancels, so it's just x squared. One of these x's cancels, leaves me minus 2x. And this whole x squared cancels with this whole x squared, and it gives me minus 8. Well, I'm almost done. I just got the easy part left to do. I take out an x minus 4. Over here, I'm going to factor x minus 4, x plus 2. And these cancel. And I'm left with x over x plus 2. Now let me show you a nice way to know for certain that you got this right. Let me erase all this. And this is a pain in the neck, but you can do it. I'm going to take any number, make it complicated, 4.23. I'm going to stow it into x. You don't want to do a normal number, just an everyday crazy number. But the calculator is going to do all the work for you anyway. I got to get this away. Get this away from my head. I know that's right next to my head. All right. Well, I'm gonna type it in anyway. Hopefully, well, let me clear this out. All right. X should still be 4.23. There it is. So I'm gonna type this crazy mess in. So it's control division, 1 minus control division 4 over x, all over 1 minus control division 2 over x minus control division 8 over x squared. And I hit enter and move it away from my big fat head, and you get 0.689. Well, crazy number. Who cares? Calculate it up for us. Now we're going to test our answer. Our answer was control division x over x plus 2. Same crazy number? There it is. Did it right. It's an easy way to check. Moving on. All right, so common denominator here is x squared again. So we're going to put an x squared here, x squared here, x squared here, x squared here. Make sure you're putting it next to the numerator so you don't do anything dumb. Nothing cancels on the first one. I'm left with x squared plus one of these x's cancels with one of those x's, 3x. Remember, we're going to multiply those two together. Nothing cancels on this first one, x squared. I can't read this next one because I made them so big. One of these x's cancels one of these x's, leaves me minus 5x. And this x squared cancels with this x squared, leaves me minus 24. Now, I'm not going to check any more of these. I think you guys get the idea about checking. If you don't, watch the video again, rewind it, watch it. Pull out an x out of the numerator. You know we're going to be canceling, so there's got to be an x plus 3, and then x minus 8. Negative 3 times, or positive 3 times negative 8 is negative 24, and they add up to negative 5. This cancels with this, and there's my answer. X over x minus 8. All right, on one of these problems, what you want to do is the same thing. We're going to multiply through by the common denominator. The common denominator in this case is c. So we're going to multiply everything through by c. C, senor. This one becomes ac plus, these c's cancel, b. What in the world is that? All over, nothing cancels here, cd. But the c's cancel here, minus b. I will get a kid that tries to cancel these b's out. Don't you dare do that. Or, oh, they're 1. They make 1. Oh, let's add 1. No, that's why they sucker you in with these answers right here. Not at all, kids. Not at all. Or a kid that thinks, oh, let's get rid of these c's here. Can't get rid of those c's here. This is like a big married couple. They're like, we're happily married. Don't break us up. Anything that's got adding and subtracting, it's got to match exactly. Don't try to cancel things like that. That just, makes us teachers cringe. This is 1 over 1 plus 1 over x all over 1 over x minus x over 1. So the common denominator here is x. So I'm going to multiply everything through by x. So in the numerator I get x plus 1. It's a married couple. In the denominator, these cancel. And I get 1 minus x squared. Well, 1 minus x squared can be factored. Now be careful, the 1 is first. So this is x plus 1 over 1 plus x times 1 minus x. It's still the difference of perfect squares. It just factors to that. The reason I put this one on here is this cancels with this. Since there's nothing left in the numerator, you have to really remember it's a 1 because these divide out and make a 1. So 1 over 1 minus x. And yes, they cancel. The commutative property of addition says x plus 1 is the same as 1 plus x. So those are the same thing. All right, moving on. Common denominator here, believe it or not, is x squared y squared. So we got to multiply everything through by x squared y squared. So let me do that. X squared y squared, x squared y squared, x squared y squared, x squared y squared. Now you got to be careful what simplifies. This x squared cancels with the x squared, leaves y squared minus this y squared cancels with this y squared minus x squared. Hopefully you see that as the difference of perfect squares. All right, here's a tricky part. One of these y's, let me try to do this in a different color. One of these y's cancels with one of these y's. So it leaves me x squared y minus plus. One of these x's cancels with one of these x's, leaves me x y squared. All right, now we got some work to do. The numerator can be factored into x plus y, x minus y. Getting serious. X plus y, x minus y. And the denominator, we can take out a GCF of xy. And I'm left with x plus y. I'm going to take an x out of the first one. I'm left with xy. An xy out of this, I'm left with just an x. When I take an xy out of this, I'm left with just a y. So this cancels with this. So there's my answer. X minus y over xy. I don't think we just got a couple more problems. Oh, there's some tricky ones at the bottom. So if you're going to stop, don't stop now. I want you to make sure you see how to do these 3 questions because they're kind of difficult. I'm about to get to them. I only got 2 weird ones left. All right, so common denominator here is AB. So we're going to multiply by AB, 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 and AB. So in this one, the B's cancel. I'm left with A squared minus A's cancel, B squared. All over. A's cancel. I'm left with B. B's cancel. I'm left with A. That's a squared, by the way. No one. All right, so the numerator is just A plus B, A minus B. And the denominator is just B plus A. But B plus A is the exact same thing as A plus B. So those cancel. And my final answer is just A minus B. Done. Wait, this looks like the same problem as this one. 1 over x squared. Nope. X squared, y squared. It's a little bit different, though. It's kind of the same thing. X squared, y squared. It'll end up being relatively similar problem than the one we did before. X squared, y squared. X squared, y squared. So, let's see. This x cancels with one of these x. So it leaves me x, y squared plus this y cancels with one of these y's. Leaves me x squared y all over. X squareds cancel, so y squared minus x squared is what I'm going to end up with. Y squared minus x squared. Because the y squareds cancel here. And it's basically the same exact problem. This is x, y minus x, y plus x. Change that to a minus. And then this is going to take out an xy, and I'm left with y plus x. Y plus x is cancel, and I'm left with x, y over y minus x. All right. So having done that, let's take a look at these. These are slightly different. Actually, they're quite a bit more difficult, only because they require you to do one step to begin with, and it's this negative exponent that causes us a problem. You need to remember that if I have x to the negative 1, that's equal to 1 over x. or x to the negative 2. That's equal to 1 over x squared. Negative exponents have nothing to do with being negative. They make things into a fraction. So this problem really becomes 1 minus. Now, the only thing being raised to this negative 1 exponent is this a. That's the only thing. So this becomes 1 minus 2 over a to the first, or just a. The only thing being raised to the negative 2 exponent is this a. So this becomes 4 over a squared minus 1. Now it's just like before. Common denominator is a squared, so I'm going to multiply everything through by a squared. In the numerator, I get a squared minus one of these a's cancel, 2a. These cancel, and I'm left with 4 minus a squared. In the numerator, I can take out an a, and I'm left with a minus 2. In the denominator, this is really a bad problem. It's 2 minus a, 2 plus a. Notice the 2 came first, so the 2's got to come first in the parentheses. Well, these cancel, but they make a negative 1 that I have to multiply through by. So my answer, my final answer, is negative 1 over 2 plus a. Don't believe me? Let's check it. We're going to use x just for fun. So I'll put my big head in this. Here's my original problem. I lost my original problem. All right, my original problem was 1 minus 2a to the minus 1. So control division. 1 minus 2. I'm going to use x raised to the negative 1. Doesn't matter if I use x or a. It's just I got a number stored in x right now. 4x raised to the negative 2. Oops. 4x raised to the negative 2. I forgot it was plus 1 or minus 1. Minus 1. And I'll just get some weird number. And I'm going to try my answer. Notice. So we're going to try. No. I was going to say something's wrong here. The way I put the denominator isn't wrong. Minus 1. There we go. Much better. Okay, so then control division. I just didn't put it in there right. Yeah, then you got to be careful if you're going to test it. Make sure you put it in there right. Negative 1 over 2 plus, we used x. Maybe I didn't do it right. It's embarrassing. And I lost my sheet because it's making me mad. So 1 minus, see if I put it in there, 1 minus 2a to the negative 1, 1 minus 2x to the negative 1, all over 4 might have to cut this out of the video. Let's see if can you guys find my mistake, or did I make a mistake checking it? It's embarrassing. Let's see. 1 minus 2. All right, now I'm mad, so I'm going to use a. 4.2 control var a. Control division. 1 minus 2a to the negative 1. 1 minus 2 times a raised to the negative 1 all over 4 times a raised to the negative 2 minus 1. And then we came up with control division, negative 1 over 2 plus a. These aren't going to turn out to be the same. All right, so I got to find my mistake. So we're going to do this again real quick. So let's go through. 1 minus 2 over a, 4 over a squared minus 1. Multiply by a squared, multiply by a squared minus, that cancels with that, minus 2a. a squared, those cancel, and those cancel. I get 4 minus a squared. So in the numerator, I'm take out, oh, there's my mistake. There's my mistake. It's not -1, it's -1a. How dumb. You see, I didn't even know, I didn't even realize I made that mistake because that thing wasn't canceled. It's got to be part of the answer. I did not do that on purpose. So let me put my answer in the proper way. -1 times a, and hopefully it's -0.677. There it is. So I thought I did the problem right. See, I just forgot, but I didn't get my answer wasn't right. Great way to check. And I did not do that on purpose. That was a complete mistake. I was a little miffed by the fact I made a mistake. So let's try this. Miffed means embarrassed, I think. 1 minus 3 over y, 9 over y squared minus 1. So my common denominator is y squared, so I'm going to multiply everything through by y squared. And let's see. Nothing cancels there. I get y squared. 1y canceled. Minus 3y. All over. Y squareds cancel here. And I'm left with 9 minus y squared. So take out a y. Y minus 3. And this one factors to 3 minus y, 3 plus y. The 3 minus y's cancel, but they make a -1. And I'm not going to make that same mistake again. My answer is -y over 3 plus y. All right, one last problem to do. This is going to be 4 minus 1 over a squared, 2 over a minus 1 over a squared. And don't you dare cancel these things out. That's embarrassing. It makes me mad. These do not cancel. Remember, there's like a big married couple here. Big married couple. Can't break up adding and subtracting. But we're going to put an a squared next to every one of these. And we're going to simplify. So I get 4a squared minus 1. And the denominator, this a cancels with this a. I get 2a minus this a squared cancels with this a squared minus 1. Again, we got a big married couple. This numerator can be factored, and since I'm running out of space, I'm going to do it right here. It's 2a plus 1, 2a minus 1. That's what that factors to, because it's the difference of perfect squares. All right. And final step. This cancels with this, and I'm left with 2a plus 1. Yay! Okay, that's day 1 review. That's it. That's all she wrote. Done. Hope you enjoyed it. All right, guys. Enjoy. There'll be more. The next one in this series is going to be, I forgot. Just take a look. Should be the next one in a couple of days. It'll be up. All right, guys. Good luck. If you like what you see, please hit subscribe. Still trying to get my subscribership up. Those of you that have subscribed, great. Hopefully you have my flashcards and you're using them. They're helpful. If not, go to mrkrausemath.com. That's how you spell Kraus, K-R-A-U-S-E, mrkrausemath.com. The directions are right there. All right, boys and girls. Good luck on the regions.